What's up, amigos? Today we have the aerodynamics of an alligator, and this alligator is kind of like in a biting pose, and I'm quite surprised by the aerodynamics. So this is a Y plane going through the alligator, and interestingly, this shape is actually fairly aerodynamic. So the tail, how it's curled, is not aerodynamic, but the head itself, how it's pointed up at an angle. You can see that the float actually stays attached fairly well. There are only some very slow-moving fluid areas where there are indentations, effectively where the neck is. And then between the nose and the eyes, there's a little bit of a trough that's also there. And then between the eyes, and then there's like another little bump between the eyes and the neck. So those regions there are slow-moving fluid, but the rest of it's quite well attached. And you think, like, with an alligator pointing up like this, you'd think that maybe there's a lot more flow suppression occurring over the back part of its head, but it actually stays attached quite well. And then in the mouth, the fluid is moving quite slowly because you can't really jam air down an alligator's mouth. Now the streamlines show kind of what I was saying before with the head, where you look at the streamlines going over the snout, they stay attached very well over the rest of the body. That's quite surprising. There's only a few little regions where it separates, and then the fluid that's hitting the mouth, the front part, has to really come around the outside because there's only so much room in the mouth that can house additional air. The rest of the body is actually very draggy. So where the tail is, how it curls up, there's all this fluid that goes in there, and then it has to redirect out, as we'll see in the next simulation. But this one, you can see that the front legs just redirect the flow. So there's like this whole region behind the front legs where the upstream velocity isn't really impacting too much. And we'll see that next. And now these animated streamlines show what I was talking about before, where the front left leg redirects the flow a lot, and then that means that the rest of the alligator, including the tail section where it's curled up, has just all this slow-moving fluid in there, and you can see that they're just meandering about, not really doing too much. They're a rebel without a cause. They're not doing anything. But the other streamlines, I should mention near the tail. Look at the streamlines that hit the tail, and they pop up so aggressively. So that's not aerodynamic. If the tail was straighter, it'd be more aerodynamic. And also probably if the alligator could sort of put its legs more down on the ground and not pop them up so much, that'd be good too. So that's the simulation. Make sure to like, subscribe, and if you want to get better at CFD yourself, and theory courses as well, we do them. We got courses for CFD. Link in the description. Peace out, amigos.